Bismillahirrahmanirrahim. Today's video is about ideal diode, and in this we'll be solving question number 4 that I had discussed in my previous video. We had discussed in the previous video that if there is a simple diode, like a simple circuit with a diode, and if we can for sure say whether the diode is forward bias or reverse bias, then there is no problem. Like in this case, positive terminal of the battery is directly connected to the positive of the diode, and the negative terminal of the diode is connected to the ground or the negative terminal of the battery. So this is straight away we can say that the diode is forward bias. But there are questions like this one. We have already solved this. Then this, and here it is difficult to say whether the diode is forward bias or reverse bias. So I'll be solving all these questions, but right now I want to solve this question, and the reason is, okay, I'll discuss the reason. Okay, when we solve this type of a question, there are two options. We can assume the ideal diode to be forward bias, or we can assume it to be reverse bias. Some recommend that it is better to consider the reverse bias scenario first. Okay, so we'll see that. Then these are some of the options that we have to keep in mind. If the diode is reverse bias, that means it is open circuited. Then for sure we can say that the current through the diode is zero, and this is, we are naming it enforced condition. But the voltage across the diode is unknown, so we have to calculate that. And if the diode is forward bias, we are assuming it to be forward bias, then we have to also make sure, or we have to enforce that the voltage across this short circuit will be zero, and we have to find current through the diode or through the short circuited diode. Then there are two important conditions from here, is that if the diode is forward bias, then the diode current should be greater than zero. And when the diode is a reversed bias, in this case, then the diode voltage should be less than zero. This voltage has to be negative. One more thing, that for every circuit that we solved, one and only one assumption will be valid. And once you have found that assumption to be valid, there is no need of doing further calculation. And finally, I want to thank Mr. Jim Stiles from University of Kansas. His slides are very, very helpful in understanding the ideal diode scenario, and he has explained with examples. So thanks, Jim. Okay, all started with this question sent by a student from Bangladesh. Assuming ideal diodes determine the voltage value VA and VB. And I had made a video on this, but after a couple of months, a student from Japan, he pointed out that your solution is not correct. Then I promised him to look into it, but I forgot. Then another student from Bangladesh pointed out that the solution is not correct. So now I'm giving this the first preference to make sure that we all understand the concept. Now for this, I have redrawn the circuit here, exactly same circuit. And now I feel more comfortable to connect batteries. Instead of 5 volt, I connect a 5 volt battery, and here -10, so I connect a 10 volt battery, negative connected to this circuit, positive to the ground. This makes it easy to write KVL equation, at least for me. So we'll follow with this. So coming back to the question, this is the circuit. We have to, assuming ideal diode, determine the voltages VA and VB. VA and VB we have to find. Okay, so as we just discussed, we can assume diodes to be either forward bias or reverse bias. Now there are three diodes that which will have 9 possibilities, all three diode off or reverse bias, and then from DLD 001, 010. So all these 8 possibilities are possible. So this is going to be a very tough working. But can we make an intelligent guess with this circuit? So let's see. The 10-volt battery, this 10-volt battery is ensuring diode D1 to be forward biased. So negative is connected to the negative of the diode. And so apparently this diode should be forward biased unless we have at the positive terminal a negative 10 volt or more battery, then this will stop conducting. But till such time VA, this voltage, is more than minus 10 volt. Now in our case, you can see there's a 5 volt battery, that too positive coming here, and this is 5 volt negative. So the maximum, let's say, we can expect is minus 5 and not minus 10 volt here. And therefore our assumption that this diode will remain forward. So we can assume that D1 to be forward bias at all the time unless proved otherwise. So we'll proceed with this assumption first of all. So when we assume that D1 is forward bias, then we replace it with a short circuit. And in all cases, in all diodes, we have to mark the current direction and the voltage direction. So this was positive here, so the current is flowing from positive to negative, positive of the voltage here. Similarly, in this case, this is the current flowing, this is the voltage direction. In this case, current will flow from bottom to top, and the voltage will also be positive at the bottom and negative. And now that we have assumed that this one is permanently short-circuited or forward bias, therefore we are left with these two diodes, D2 and the D3. And here we'll have 4 options, that is both of them could be reverse bias, and then one reverse, one forward, etc. So we'll see, we'll just name them assumption number 1, assumption number 2, assumption 3, assumption 4. So as I told you, it is better to start with the 0, or the reverse bias case. So we'll do that. We'll start with assumption number 1. Okay, so assumption 1, D2, D3 are off. So off means we have just open circuited these two. And then there's very important thing that whenever we are working with the circuit, especially when it is off, then we have to use this technique that when the diode is off, we have to put current 0 in forced condition, and we have to find the voltage across it. So we can just add here that ID2 should be 0 here, and VD2 we don't know. In this case also ID3 will be 0, and VD3 we have to find out. Okay, and now this you can see is completely kind of independent, and the same current is flowing through this whole branch, nothing going this side. So we call it I1 current throughout the branch, and then we'll solve by KVL equation. So KVL left loop. So this loop, we're starting from here, so it is minus 5. I1 into 5K, coming down, it is I1 into, ID1 is same I1 here, so I1 into 5K again, and this minus 10 volt battery. And from here, we find I1 to be 1.5 milliampere. Now, just a point here that since ID or I1 are same is 1.5 milliampere, our logical assumption that D1 is forward bias is proved to be correct because the current is flowing from top of the bottom or from the anode of the diode to the cathode of the diode. Therefore, this is forward bias, just on the sideline. Okay, now again by this loop, but we want to find out VA, so we'll stay up to this point. So minus 5, I1 into 5K plus VA is equal to 0. I1 or I1, 1.5 milliampere, so putting that, so VA is now minus 2.5 volt. Okay. And to find VD2, we need to find VB. And since no current is flowing through the mid branch, now look at this branch. No connection with the ground, neither from this side nor from this side. That means there will be no current flowing and there will be no voltage drop across. That means whatever is the voltage here will appear at this point. That means VB is minus 5 volt. So VA, VB known, we can find VD2 is VA minus VB minus 2.5 minus 5 is plus 2.5. And now here we have to use the condition that for reverse bias, we have assumed it to be reverse bias. For reverse bias, VD has to be less than 0. In our case, VD is positive, not minus. VD is not less than 0. And therefore, we say that this is a contradiction. And now here is another important point. Since we have found one contradiction, there is no need to check further. So we have found this contradicting, so there is no point going here. We just move to the next assumption. Okay, the next assumption, first one is done, and 0, 1, that means D2 is open, D2 is open and D3 is short. So D2 is open and D3 is short. And here also now we'll impose the conditions that in case of an open, the current will be 0, we have to find the voltage. And in case of a short, the voltage is 0 and we have to find the current. And since this branch is still independent because of the open circuit, therefore we use one current for the top and bottom. So again, we have already in the previous slide find out the voltage VA, just reproducing the technique that we followed. So we can write that VA is minus 2.5 volt. What about VB? Now VB is now connected to ground through this. VB is connected to ground and therefore VB is equal to 0 volt. So this is same, VB is 0 volt. Don't have to calculate current. And from here we can write that VD2, this VD2 new now, is VA minus VB minus 2.5 minus 0 is minus 2.5. And now our logic fits here that RB should be less than 0. For reverse bias, VD should be less than 0. In this case also, VD is less than 0. VD is less than 0. Therefore, D2 open or reverse bias is confirmed. So this is confirmed. Now we have to confirm the other one. Okay, so let's see that. By KVL right loop. And since we'll be using current, so I'm just marking the direction. I forgot to mark earlier. And now by KVL, we start from here, positive 5 and minus sign. So minus ID3 into 5K. And this is going to ground, so 0. And from here, ID is 5 divided by 5K, 1 milliampere. And is it following the convention? So for forward bias, ID has to be greater than 0. In our case, ID is of course greater than 0. It is positive 1 milliampere. Therefore, this assumption is also valid. So D3 closed is confirmed. So assumption 2 is valid because the reverse bias has been confirmed and the forward bias has been confirmed. So this assumption is valid. And now, as we discussed earlier, we have to keep in mind that for every circuit, one and only one assumption will be valid. Now, since we have found assumption 2 to be valid, so there is no need of going further. And from here, we can find the answer, that is VA. This was the question, find VA and VB. So VA is minus 2.5 and VB is 0. Where is it? From here, you can see that VB is 0. I have written it somewhere. Okay, yeah, this one, VB is 0. So this is the answer. But you might ask that we have not tried these two options. What will happen if we start from the bottom, from all forward bias and then go to the options? So just for the curious mind, I'll do it this way now. I'll first solve assumption number 4 and then assumption number 3, and hopefully we'll find that assumption 2 is correct. So let's see. But this is not part of the solution, just for your curiosity. So assumption 4 says both are short. So both are short. And as we said that when it is short, the voltage has to be 0. We have to find current. Here also VD is 0 and we have to find current. And since VB is connected to ground, therefore this is 0 volt. And since this is also short circuit, therefore VA is also 0 volt. Okay, and now we take a current I only up to this portion, because now this current is dividing into two paths. So we'll just call it I. And this is I1. I'm just marking the resistance polarity so we can easily write the KVL equation. Okay, so the KVL left loop from here, minus 5 I into 5K is equal to 0, this point. And from here, I is 1 milliampere. So this current we have found 1 milliampere. Now, this loop to find ID1, so we go from here, KVL plus 10, and then since it's minus coming first, it is minus ID1 5. So minus ID1 5 and going to 0, so equal to 0. And from here we find ID to be 2 milliampere. So this current is 2 milliampere. And now if we apply KCL at this point, then you can see I is equal to ID2, ID1. So I is equal to ID1, ID2. And from here we'll find ID2. So I is 1 milliampere, ID2 2 milliampere, ID1 1 milliampere, ID2 we have to find. And from here, ID2 is minus 1 milliampere. Now what does this mean? That the current actually is not in this direction, rather it is in the reverse direction. So let's go to the condition now. For forward bias, ID has to be positive. We have assumed this to be forward bias, but ID is negative, therefore this is a contradiction. So the assumption 4 is not valid. We have found one contradiction, no need to check further. Okay, now let's go back and see the other option also, 1, 0, just for your satisfaction. So this is 1 and this is 0. Current dividing, so just same current. KCL at node. Now here we'll write KCL. This current entering is ID1 leaving, ID2 leaving. And in terms of voltage, like nodal equation, we can write I is 0 minus V1 and this is adding to the current, therefore it will be plus 5 divided by 5K. Similarly, this one is coming VA from here, it is going down. So VA minus going to ground 0, and this is also adding, therefore it will be plus 10 divided by 5K. And similarly, this one, now this is open, so this current is actually going through this resistor and the battery. So we can say that VA minus 0 plus 5 divided by 5K. And now, since there is LCM 5K, so we just do away with it. So this will be the equation. Simplifying, we find VA to be minus 3.33 volt. Okay. But VA and VB are same, so because they're connected through short circuit, so VB is also minus 3.3. And now VD3, this one we need to find. This we have found, this is ground. So VD3, and the very important point, we should not take it VB minus ground, because the polarity is positive at the bottom. So we have to take ground first. So ground or 0 minus VB. So this is important. So 0 minus VB is 0 minus VB is minus 33. So it is 3.33 volt. And for reverse bias, we know that VD has to be less than 0, but in this case it is positive, not less than 0. So there is a contradiction. Therefore, assumption 2 is also not valid. So we can safely conclude that assumption 3 is not valid, and therefore we had concluded that assumption 2 is valid. I hope you have been able to follow this. Please let me know through your comments. Thank you.